It's 6 o'clock now, so I guess we'll get
Yes,
started.
we are to start. And we
Yes.
have 12 participants, which is a great number of participants, even though 2 of them are the hosts. And we have here Gordana, who is going to also show us some nice stuff. And who else do we need? I don't see Andrea and Monica though. But Monica was here, wasn't she?
Yeah, Monica was definitely here.
Yeah, Monica is here. So from the presenters, I'm missing only Andrea, I suppose.
And hopefully she'll be here shortly.
All right.
So welcome to everyone who we haven't said welcome to yet. So I'm joined by Nasko, who's co-hosting this experiment share with me. And can everyone else, if you haven't yet said hi, either quickly turn on your mic and say hi, or if you prefer saying hi in the chat, and say hi and where you're from. It's not a lot of highs. We get 2 people from the chat who are driving, so won't be talking too much, but listening to what we're saying. Today's theme is paper. So as you can see, I've got lots of different paper surrounded by me. And the idea behind paper is that it's one of the most commonly available materials. I've been in schools all around the world, and I've had teachers all around the world complain to me that they don't have equipment for experiments, but everywhere I've been, everyone has paper. So if we can share a couple of our favorite experiments with paper, then that should be things that most of us can use as soon as possible. So with that being said, I'm not used to hosting with more than one person. Nasko, do you have more things to say, or have I been cutting you off too much?
Paper is versatile, paper is available, so it's the greatest material that there is. And today we have plenty of interesting things which are reaching out to touch paper. So I suppose we should, if you don't have any opening words of what actually we are doing here, then we should go to the first experiments.
Perfect. Oh, and then in between experiments, you and I will keep coming on and presenting parts of different experiments too, right?
Yeah.
Perfect. Okay, so that's enough from us. Now we'll go to Gordana in Serbia, who's joining us. So I'll change the spotlight. Now we're all 3 spotlight, and I'll gradually fade Nasko and I out. Great to see you again, Gordana.
Thank you very much. Hello to everybody. I have to go to school again, so I will be short to show just this. Today we work again in school after 3 months in Serbia. We come again into school, and so it was a good time to show the kids this. This is elastic gum. How do you call it, Michael? This is
elastic band.
Elastic band, rubber band.
Yeah.
There's many different terms. I always seem to use the wrong one, but yeah.
And just one piece of paper, and here is one straw inside. In the middle of this is one straw. So you can make this a butterfly or a bird or something else. Kids like to play very much, and you can now it's not easy to explain this experiment because you have a friction, and also you have elastic forces, and so it has to go up this fly, but I didn't have time enough to try it. Just we have to take on this way, and it is going to make a balance and going up and up. So I share with you a link for this.
I'm sorry to interrupt. For me, it seems like your video's been freezing a bit, so I haven't seen it that clearly. Now it seems a lot better. Yeah. In case the problem's been the same for other people, if it's been on your end, can you show that last part again, please?
Okay. Here I have just a piece of paper, and so I have this in the middle. I put one thinny straw, but you have to use just right elastic to be this comfortable to show all of this I want. So you have going up. You have it to going up, but I can't do it. I can't do it to try it at home, you know. But so I share with you link when you can see everything.
Yeah, in the chat there is a link from
Yeah, in chat.
Gordana
I put it. Yeah,
with the
maybe you can
oscillating woodpecker.
yeah, maybe please Nasko share with us to show on our screen this
All
link,
right.
please.
Right
Thank
away.
you very much.
All right.
Mm.
Share. So
And while Nasko's
now,
doing that, I'll share the link
Yeah.
again because I see Andrea asked. I think she hadn't been here when it was first joined because it was shared a little bit earlier. So if anyone needed that, there's the link again.
so there is how to make the oscillating woodpecker.
Yes.
You see
Maybe
my screen
another
with the woodpecker?
scrolling. Yeah. Yeah.
All right. And so they, of course, you can do whatever animal you seem fit. It may
Yes.
be a butterfly like in the Gordana's case, or it may be the woodpecker like in here. And the important part is to tape the straw right where you want the thing to have the pivot point. In the case of Gordana, you see it's the butterfly body.
Yeah.
And then you just cut a rubber band, and then trying to pull the rubber band will cause our animal to get some friction,
Oscillate.
but it will be it will be not only from, it will be only from one side, so different oscillations will make it go up on the rubber band. And of course, the important part that Gordana already told you is that you need to make your straw a bit smaller, so more friction could be presented.
Okay. Yes. And but teacher always have to be good prepared for this. It is very easy when you look something on the internet, but when you try to do it, not so much.
Of course, Gordana, but that's a really cool and nice experiment. And
thank you, Nasko, for helping me. Thank you. Thank you, Michael, and all of you. Thank you very much.
Thank you for starting this one off, and I'm thrilled to hear that you're finally back at school. I know things have been difficult in Serbia recently, and it's getting back to school is a good sign. So hopefully your students are very happy to see you again. I know I would be.
Thank you for supporting us. We are suffering so much on these days and these months, but I think it's been good. It's been better. Yeah. Thank you very much.
Cross it will become even better.
Thank you very much. See you. Thank you. Bye.
Thank you. And then Nasko, how about one of us or both of us together?
Well, let's go with the classic, shall we?
Yeah. So this is one of our all-time favorites, and there are at least two people currently in a car for this. So I think we should mention Nasko has presented this from a car when I was live with teachers at Gordana's school. What was I there, or was I in Lazar events? I was somewhere in Serbia.
Well, you were in Serbia, but you didn't tell me where exactly. So
okay, I'm pretty sure Gordana can correct me if she remembers better, but I think it was the time we were doing it at Gordana's school. So anyone who's in a car, you should have toilet paper with you to follow along live. And Nasko, do we want to, oh, I should spotlight us again, so people see us big if they, without changing things around. Do we want to ask people to try and find toilet paper if they have some nearby?
Well, if they have some toilet paper nearby, we can wait for 30 seconds for people to grab toilet paper if they wish to. All right, I see people going for toilet paper. All right.
And that gave me time to figure out how to spotlight us both. I don't know why, with how the menu's organized, it takes me so long to switch. It used to be so much quicker.
Well, it is more people are using Zoom nowadays, so they are making it worse.
Yeah, I guess so.
Paul says he never has toilet paper in his car. Shame, Paul, shame.
Maybe that says he has more reliable bowels than I do. I don't know.
All right, so what we're going to do is we are going to look at a really easy experiment with toilet paper, which speaks about the direction of the paper. So we are going to need 2 pieces of toilet paper. All right. So paper, mostly, in most cases, is anisotropic material. So it behaves differently in different directions. And it is so because it has fiber in it, and the fiber is in that direction. So here it should shear finely, here it should not. And we're going to test that. So you have 2 perforated edges, right? And 2 straight edges. So we grab the paper so the perforated edge is on the top, all right? And we are going to pinch one side with finger and a thumb, and the other with the pointer and the thumb, right in the middle. And on 3, 1 hand forward, 1 hand backward. All right, 1, 2, 3. And it sheared straight through the middle. And it's perfect because we have, both of me and Michael have done that in a lot of continents, and most toilet paper will do the trick. So I have one from Europe and Michael has one from South America, and they work. That's nice. So let's see if I'm lying to you. So let's grab our second piece and hold it now on the pristine edge, not on the perforated, but the other one. And we're going to once again pinch it here and here. And on 3, we're doing the same stuff. So 1 hand forward, 1 hand backward. So let's go. 1, 2, 3. And it doesn't shear well. And if we look closely, when we have grabbed it, it actually broke, and then it sheared along the what? The long side. So now let's get back to this one. Let's hold it with the with the perforated edge, but the one that's all right. And let's grab it again. Michael, you're holding it wrongly. On the perforated edge, no, the other one, the other perforated edge, the other perforated
edge on top.
Yes, exactly. So 1, 2, 3, and now again it shears again quite easily and to the side. So now the best part, if you're doing that with small children or with adults or with teenagers, everybody loves that. So we have 1 piece and we have 2 more, right? Let's grab all of them, all the good pieces. So all 3 of them, the 2 from the last one and the one beautiful from this, and let's hold them together with the perforated edge on top, the 3 of them. So let's try again. 1, 2, 3. And it sheared really, really easy because this is the way, the shear direction. And let's try just one more time, all 6 pieces together with the perforated edge on top. And 1, 2, 3. And now the best part, because if you hold it together, if you hold them together like so, you have a pom-pom. All right. So with that intermission, I think it's time for us to get back to our next participant, and I saw her in the list of people who are there, and that should be Andrea McPhee.
Exactly, and just as I'm switching the camera to show her, I want to mention she's joining from Toronto, Canada, which is where I grew up, and she was one of the participants in the first ever experiment share, August 2021. So a number of years ago. So it's great to have you back, and I'm looking forward to seeing an experiment from you today.
Thank you so much. I'm sorry, I'm on my lunch period right now, so I'll have to go. And if you hear people yelling outside, there are some very excited students in the halls.
Well, that's
So
great you made time. Thank you.
So I saw a paper and I was like, oh, I get to share one of my favorite, very, very simple demos. I'm a big fan of using the predict, explain, observe, explain sort of progression to help explain stuff, to demonstrate things, and to lead into teaching specific concepts. And this is for the this is a series of demos that will help explain the sorry, my brain is gone. The people outside are yelling and I forget what this is demonstrating or what it's called. But basically the fact that heavy things do not fall faster than light things. So the acceleration due to gravity, that's what I'm trying to say. And one thing I will preface this with is that it's really important when you do demonstrations. This might be better actually as like an actual lab to do with students, but it's really important to get them to really, really think about it, because you will get students who will, if you just do the demo and you don't do any talking about it before or after, a lot of research has shown that students will sort of double down on their misunderstandings and their misconceptions. And of course, we know the biggest one is that heavy things, and the heavy things are going to be a lot of paper. Sorry, I'm going to unblur my background and try not to show you how messy my office is. That heavy things are do not in fact fall faster than light things. And so what you need are essentially 3 pieces of paper, and I try to make them sort of identical, because you've got the Larry lawyers who basically will say, well, I mean, there might be a little bit more ink on that one. But why 3 pieces of paper and a textbook? And why 3 pieces of paper? Because we're going to put one of these pieces of paper aside for later so that they don't know. But we're going to do, 1 piece of paper is going to be cut up into a ball like this, right? And the other piece of paper for now is just going to stay a flat sheet. And then the third paper is going to come in later, because we're going to crumple this one up into a ball as well. And so what I have the students do is I let them know I'm going to drop 3 sets of objects, and I want you to tell me which one is going to land first. I'm going to drop them from the same height. And I got to tell you, I usually go in and I stand up on a lab bench and drop them from the ceiling and try to make it very, very dramatic. And I sometimes have to go through like, this is what it sounds like when the textbook lands first. But you get them to predict which they think is going to land first. So the crumpled up pile of paper or the flat sheet of paper. And then you say, well, then what I would do is I'm going to crumple up this flat sheet of paper, and I'll just do it straight. So you crumple up the flat sheet of paper, and then I'm going to drop those same pieces of paper, but now the second one's also crumpled up as a ball. And then the third set that I'm going to do is ball versus lots of sheets of paper, aka the textbook. And this is an old textbook, so it's okay if it falls a great distance, it lands. And you get them to predict what they think is which one they think is going to land first, and also why. And we spend a lot of time actually discussing this, and they usually get sort of the right idea, and they sort of know why this one's going to like fall down after. You will get some students who, when you look at the crumpled sheet of paper, they will say, oh, well, which one is crumpled up more, and which one's can't. It's like, okay, guys, yeah, I don't, it ain't that deep, right? Although you do want to try to make sure that you're not accidentally dropping one a little bit lower than the other, because if one does land before the other, then you have a whole world of problems. But basically, of course, we know that the issue comes in, you know, with this one and what they think is, which one they think is going to land first. And I will say, spending time, it is worthwhile, I think, spending time doing this demo. I have, again, this is just not very good data because it's just my observational data, but I'm just remembering one year I had a class of grade 12 students who had all taken grade 11 physics, and half of them had taken them with me and half of them had taken them with another teacher. And I know the other teacher talked about this, but I know I specifically went through this demo. And I bet when in the grade 12, when I went to review which one is going to land first, about half the kids said this would land first. And it wasn't 100% all, you know, his students versus my students. But I think it was like all but one of my students knew that they were going to land at the same time. And all but one of his students thought this one would still land first. So even though I know they had been taught this stuff, actually taking the time to really interrogate that and get them to sort of think, why is this happening? You know, they will actually understand it better. And this one, you might find yourself having to drop a whole bunch of times. This is actually why I find standing on the lab bench and having a ceiling really handy, because I'm like, I'm going to drop it from the same height. And there will definitely be somebody who said, oh no, the textbook landed first, and everybody else is going to be like, nah, man. But this is where the secret fourth part, which I don't tell them what I'm doing ahead of time. I will say, okay, so what I'm going to do is drop the same sheet of paper, but now it's a flat sheet of paper against the book. And what I'm going to do is try to eliminate all of the air resistance, because they say, well, why does this fall more slowly? Because there's air resistance. So I'm going to try to eliminate the air resistance. And the way I'm going to do that is I'm going to put it on top of the book. And now this book actually happens to be the same size as the piece of paper. It's actually slightly better if it's not, if it's a little bit smaller, or even if it is, and I'm trying to show you this with my background here, even if you get like a little bit of it off like this, so they can actually see that there is air resistance pushing this up. You don't want to do too much. You need to test out how much that would need to happen, how far over it would need to be before it actually does lift up. But the reason why I find having even just this little bit, because they can see that as it falls, it sort of lifts up and goes down, but the rest of it stays, and you're not getting into this is developed because we wound up having this whole conversation about maybe there's some kind of there's pressure pushing down on this, pushing it down. But we also talk about, so if these landed at different times, if it didn't have anything to do with if we were eliminating the air resistance here, so if mass really made a difference, then what would happen? You'd expect this to lift up and then this to fall faster, and so this would land after, and it would come after. But then what actually happens, and it's really, really dramatic, is that this will fall down. And I don't want to take too much time. Let me see if I can unblur my background. Okay, and then I'll just demonstrate here. Okay, so you get very, very dramatic, and you call it out, and you say 3, 2, 1. Okay, and it's very loud, and this may go sort of flying after, but what it does not do is like fall down separately like this. And then you can get into what I like about using a book, why I like using a book for this, is that you can get into Galileo's thought experiment, which is like, this is just a whole bunch of pieces of paper. How come they are all sticking together? Imagine if we separated the book into 2 different parts, right? But we somehow managed to attach it, and you can get into the whole thing about, we had the say the 2 kilogram mass, and you split it in half, but they're still attached somehow. How would those fall? Like, those would not fall faster. And so it's that sort of thing. And then you can get it also, actually, I'm not sure if that was a Galileo's thought experiment or a Veritasium thought. Somebody came up with this as a really good explanation for this. But that's basically it. It's very simple, cheap and cheerful, and then you can actually reuse these if you don't want to waste paper. But it's a nice light thing. And then if you get students who say, well, that's not enough of a difference, that's when you pull out the paper clip versus bowling ball or shot put thing, and then you can use the textbook as something to drop the thing onto. But that's basically it. It's very, very simple, but I think it's a very handy way to really get at that thinking and to get them thinking about what's going on in the physics, and also discussing it beforehand is really, really important. And get them to vote. Who thinks this? Who thinks this? Why do you think this? You're allowed to change your mind before we do it. And you can also tell who's sort of been paying attention by this third one, because by this third one, by the fourth one, usually most of the students are like, nah, they're going to fall at the same time, because I don't think, we took out air resistance. And so that was the only thing that was making the paper fall more slowly than the other paper. So that's it. There you go.
That's awesome. Thank you. I love dropping things and things falling. So I'm going to show a couple simple things that I cut in the background while you were showing that. But before that happens, does anyone else have anything to ask, add, or explain? No, so silence. Okay, so I'll show it a couple of things, because it reminded me both of doing that exact same experiment, but one or two other things that I do as well, depending on the group I'm with, or depending on kind of what makes sense to do. And one of them is to retake the idea of the textbook and the paper, only here I just have a notebook, which clearly if I drop them at the same time, the notebook is heavier, it'll overcome air resistance quicker, so it falls quicker. But air resistance is less negligible for it than for the textbook. It won't be fully negligible for a textbook, but you can see that if instead of dropping it with the paper just on top of it, I actually have it separated. And even just with the space at the desk, I should be able to start it like a centimeter to higher, and it falls faster and catches up to the notebook on the way down. So I'll do that one more time. If it's not clear with this distance, I'll stand up so we get a bigger distance. But it is catching up to the notebook on the way down, which shows this actually can fall faster than this one, which can surprise people that not only can they fall at the same rate, but because this one only has a tiny bit of air to go through, and this one has a lot more air, it catches up on the way down. So that's one thing I wanted to show. Another related thing I was thinking of was, in my first couple of years of teaching, it was often quite difficult to plan lessons to last the right amount of time. I mean, it still is. That's a challenge, and it's good for teachers to have points where they know they can cut something short, or ways they can extend things. But my first year or two, I'd have times there'd be like an extra half hour that I didn't plan for. So one of my go-to challenges was to try and drop paper, either to get it to fall the fastest as possible, or to get it to fall the slowest as possible, which leads to a couple of interesting design things. Like here, I'll need to stand up, but I just cut, while Andrea was presenting, this little like folded helicopter out of a sheet of paper. It's a fairly well-known like way to fold and make a helicopter. It's not a very good one, but you should get the idea that it should twist around as it falls. And I need to show a little bit lower. Was any of that on camera?
Yes, the lowest part was visible.
Okay, so the lowest part, and it was spinning. So students can iterate through different designs of this, and it's a good use of scrap paper. Or a simpler, more elegant one is just a strip of paper. So cut a simple strip. And if we twist it around on itself, then it can also fall down slowly. It doesn't fall in a straight line, so it's difficult to get it to behave and stay within a camera frame. Try it at home. It doesn't require much material, and then you don't need to worry about me not keeping it in the frame. And an interesting thing is if we switch where it was attached. So it was first attached here, so we have like long tails on it. And then if we switch it so it has short tails, it'll change the orientation in which it spins. any of that on frame?
Yes, it looks like it's vertical with the long ones and horizontal with the short ones.
Exactly. So just with a small design change, and you can have students try and figure out what's the point where it changes or what's the ratio it changes. So there's a lot of things to play around with that. And then a completely different but like way of looking at this. So I mentioned just before introducing Andrea that I'd grown up in Toronto, Canada. I think you could call it the national tree, like the maple leaf is on the flag. So it's certainly got a lot of importance for the symbology of maple in Canada. Their seeds and how they disperse seeds are these things called maple keys, which spin around as they fall off. So in the fall, in a lot of parts of Canada, especially the Toronto area, it'll be a common sight when you're walking down a street to see maple keys when there's a gust of wind. They'll be spinning around and falling. And they evolved that way so that they could spread further than falling straight down. I was amazed a couple of days ago in Paraguay in South America, completely different vegetation. It's a tropical country. There are no maples here. There's a different tree, completely different leaves. I don't think at all related to a maple that had convergent evolution. They had these same seed pods that looked just like maple keys. And so it was a neat example of convergent evolution that only came up because I was showing dropping one of these things. So that's a couple of dropping paper things that I wanted to add on because I always like it when some of us see an idea and they can be like, oh, that reminds me of this thing that I want to share too. So that being said, if anyone has anything that reminded them of that they'd like to share, please jump in. If not, Nasko, do we want to continue with more toilet paper before we go to Monica and Romania?
Well, I think yours with the little addition were the perfect transition for what we are having next. So let's just go for it. I suppose if Monica is ready, we can give her the floor.
Yes, hello. I'm Monica from Romania. I'm a kindergarten teacher, so our experiment was more easier and fun. We made a tissue paper caterpillar. The students draw a design on the piece of tissue. They roll it out on a skewer and glue the end of it. After that, they removed the skewer by sliding the tissue, and then placed their caterpillars in a tray. And using a pipette, they added droplets of water on the caterpillars and watch them wiggle. I have a video if I can share it with you now.
Yes, please do. Yeah.
Go for it.
this was our experiment with the tissue paper. The kids were very delighted by the experiment, and they have so much fun doing it.
Well, one may say that they observe caterpillar emotion.
Yes.
Oh, that's wonderful. It sure looks exciting for them to do. That's yeah, I like that one a lot.
Yes, yes,
Are there
yes, it was indeed.
are there any questions on that or any other thoughts on that?
Great experiment, Monica.
It looks like one of those really nice experiments for younger kids to make them curious and to spark the curiosity in them. So it's a great one.
Thank you very much.
Thank you.
All right. So any other questions and comments on Monica's experiment? And of course, her maybe how the kids react and whatnot. All right. So thanks again, Monica.
Thank you
A
too.
really great experiment.
Thank you.
So, Michael, it's time for us to do another one, is it not?
Yeah, that sounds great.
Do you want to blow on some paper, or should we try to break apart more toilet papers?
What do you feel like?
Well, I'm fine with either. We can, people have their toilet paper already, so we can do one of those.
Let's continue with toilet paper and use the burning near the end, kind of like as one of the finale parts.
All right. And you're going to do the burning?
No, I didn't plan on burning it.
Oh
Do you have
no.
stuff to burn? I don't have a pH indicator. I thought you always have pH indicators on you.
Well, yeah, but I'll be needing a few minutes to have it on myself, but we'll figure it out. All right, so let's then again go to our toilet paper. We're going to need 2 more pieces. So who's following along should have 2 more pieces. And we are going to talk friction because we have the cellulose fibers who are touching each other, and they're touching gently and softly now. And we can try to see how hard they touch. We are going to hold it with the normal edge up, so it's the longer edge on top. We're going to fold it once, like so, alongside. We're going to fold it twice, like so, on the long side. And we're going to fold it thrice, so once again. All right, and now we are going to do something really simple. We are going to try to take it apart. So the only motion that we are allowed to do here is spreading our hands. All right, so we hold it, so we see some part of it, hold it strongly and pull apart. 3, 2, 1. And quite easy, isn't it? Because there is not a lot of friction between those fibers. They can actually slide away from each other. So what we're going to do now is enforce more force. We are going to put in some more friction. So we are starting with the same type of sheet of paper in the same direction, and we're going to fold it once and fold it twice, just as before. But now we're not going to fold it thrice. We're going to start making into a wick. We are going to start twisting it. So we want to twist it really, 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 really hard. We're going to need a really tight wick. So we are going to twist it so much so that it starts to try to bend. All right. So it should start to bend on its own. And when it starts to bend on its own, then we are ready. And if it starts bending, we hold it the same way and try to pull. And if you have done it good enough, it should be a bit more stronger. Yes. And it should be a visible or feelable, tangible strongness intensifying, because now the fibers are with each other and they are holding really, really greatly. And you can actually try that. You can touch your hands and just slide them. And now gently put your fingers without really squeezing. Don't squeeze. Just interlace your fingers and pull. And you'll feel a bit more friction. And this is what happens with the paper. All right. So I suppose that's all right amount of toilet paper for with the breaking. So I suppose.
While we have this handy, do we want to reduce the friction and see what it looks like if we lubricate
All right,
it?
we can take another piece and try to reduce the friction from the wick.
I didn't manage to break mine.
Really, it's quite hard.
You didn't wind yours enough if you managed to break it. Or at least that's what I tell students. Like if I'm doing this with students, there's often like a tough kind of guy who's like, yeah, I can break mine. And so then I hand him one that I twisted really hard and I say, okay, try and break this. And usually if you've twisted it enough, a regular strength person, even like a fairly strong person, won't succeed.
All right, so I have another one now that's quite stronger, but how to make it weak again? Well, the fibers can be lubricated. So we're going to do exactly that. We're going to lubricate those fibers with just a little bit of water. And Michael has planned ahead and he has a cup of beverage, which is water-based, I suppose. And I have myself.
And it's water. It's just got a bit of ink in it. You'll see why in a moment.
Yeah. So now, if our fibers are lubricated with water, it's quite a lot easier to break it apart, because now our fibers, and you still can do that. So the fibers not entangled your hands, the fibers entangled your fingers, and then you just grab a bottle of oil, you oil your fingers and try it again, and it will be really, really easy to spread them apart. And now I'm going to prepare the last one, and Michael is going to introduce you the next experiment that we are going to see from our South American friend over there.
Excellent. So I'll be introducing Maria Soledad, who is also right next to me, but I'll switch to her camera for two reasons. So I'd mentioned when I sent out the invitation and the Zoom link that we're going to try options for translating from different languages live. It turns out to be harder than I originally thought. So Zoom has auto-transcribe settings for captions, and I'm going to encourage you to try and put those on now if you haven't bothered using them. The problem with that is they no longer support, and they used to support, machine translating what they auto-transcribe. Now they've gotten rid of that feature and only do it with third-party add-ons, which we could use, but I'm going to use a different option, which I'll explain in a second. So I'm going to start sharing my screen to show Zoom itself. I changed the settings so it should show Zoom, even though by default it doesn't. I'm guessing, no, it doesn't, even though I asked it to. How do I change? Okay, I'm going to try that one more time. Otherwise, I'm just going to talk you through how to find the caption settings. Close. Okay, let's try this. No, you're seeing this document rather than my screen. What do you, yeah, no, that's not working right. Okay. Never mind. The captions should be in one of the bars at the bottom, and as I toggle them on and off as the host, you should be getting notifications, like it should turn them on and off. And we can see I can turn them from English, and it's writing what I write in English. And now if I turn it to Spanish, then it won't make any sense of what I'm saying in English. It'll try and find Spanish words that sound like what I'm saying. And it just comes up with a lot of nonsense. There's a couple second lag to do that. So that doesn't work as an option either. Some add-ons work, and there's one I tried that worked really well, but it messes up the recording. So instead, what I'm going to do this time, and let me know how it works, I'm going to switch it so I'll be typing manual subtitles as Maria Soledad presents the experiment. So switching to that right now. Okay, so now I'm typing subtitles or captions. And it's me typing it, which is why it goes back and forth and has whatever mistakes I make. And so now I'll turn things over to Maria Soledad, and she'll introduce herself, and I'll go through captioning it, and I'll, for the most part, stop talking. We're going to see how this works. Again, thank you everyone for your patience while we're trialing this. I think it'll be really useful to have things working better, to have like this as a way of encouraging more people to present. And the first couple of times we go through it, it might not work that well. But if there's any, like if you have any questions, if things don't work well, just let us know. We can change how we're doing things. But let's give this a try. So can you turn on your microphone and introduce yourself? And I'll turn mine off so we don't have.
Hello. El experimento que voy a hacer se llama el arco iris que corre, sería en español. Lo que vamos a necesitar serían 2 vasos con agua y papel de cocina de este tipo. ¿Todo bien?
Just to interrupt for a second. So I mentioned captions and I started trying to tell people how to find them, but I didn't check and ask, has everyone found where captions are? Because if you haven't figured out where to turn captions on, you're not going to see the captions I've typed. So just a quick, give a thumbs up to their reactions. Give a thumbs up if you managed to turn captions on. If you haven't, then I'm going to go through explanations again, because it doesn't make sense typing captions if people aren't seeing them. So can everyone give a thumbs up, either reaction, like I'm typing the reaction button here and reacting with thumbs up, or on your camera? And if you haven't found it, then like if there's a lot of people who haven't found it, I'll explain more detail. There's no thumbs up I've seen. So either I'm not seeing things right, or I need to explain a little bit better where the caption settings are. So the caption settings, turn captions on in Zoom, are Depends if you've had them on yet or not, but if you haven't, then they'll be in the plus or more menu. Could be called something different if it's in a different language, but it should be on the bottom right, right next to the meeting option, and it should be one of the first three options from the top, either called captions or subtitles. And when you click on the menu, it'll pop up with a different menu. One of the options will be to turn them on or off. Hopefully, that's how people find them. Can you? In the chat, you either write yes or no if you have the captions on. So again, by writing in the chat, can you please either say yes, which means yes, you found how to put captions on, or no, no, you haven't found how to put captions on. Okay, we have at least one no, which means it's not clear enough. No other yes. Okay, not showing either. Okay, that makes this a good opportunity to try another option that I've been exploring. And the only problem with that, it might mess up the recording, but I'll deal with that afterwards if it does. So I'm going to try a Zoom add-on, which is there are add-ons to Zoom. And this add-on seems to be one of the best ones that could exist for this. It's just that it's a little bit of a hassle to actually use. So it's called Event Cat, and I'm turning it on as we speak with a couple of clicks. You'll see it will appear like another participant in the meeting, but then it should be adding live translation. Just a couple more clicks to go. Okay, so we Okay, so we now have the event chat bot that's in the meeting, and I just need to figure out how to get the captions on. Okay, and that appears open for me, but it doesn't look like it's open for. Okay, no, it is. Okay. Now all we need to do is. It should have put a link in the chat to go to a transcription. Yes, so there's the link in the chat. Theoretically, when you click on that, you should be on the transcription, like the live transcription, which is what I'm on and it's writing down what I say. It should also be able to write down anything said in Spanish as well, which is the other language that's been activated. And then as the person watching, you should be able to toggle between the two. For me, it works. But again, I've been testing this before, so I know what it looks like. Can everyone else try clicking on the link in the chat for Event Cat and see if it works for you to see a transcript as I'm speaking live? And then if it does or if it doesn't, please share in the chat either yes it does or no it doesn't.
So I suppose that's a yes.
Oh, that's a great idea. Nasko started sharing his screen. So, Maria, can you start talking again so we make sure? Yo fui a español y vamos a ver si capta que he cambiado de idioma y vamos a ver, es algo lento por... No, that doesn't seem to have captured that I switched to Spanish.
No,
Maria, can you start your explanation? Puedes intentar la explicación de tu experimento y vamos a ver si funciona ya. Y si no funciona, vamos a hacer la última opción.
Bien. Necesitamos 2 vasos con agua. Y un trozo de papel de cocina. Que vamos a doblarlo por la mitad y luego de nuevo doblarlo, así. Luego vamos a marcar en las esquinas, como doblarlo en 2 partes. Y vamos a utilizar pinceles para hacer ya sea el arco iris o del color que quieran usar los niños, porque son experimentos que le encantan a los niños estos. Y vamos a colorear los bordes que hemos marcado aquí para aquí. Y de este lado el mismo color y así sucesivamente va a quedar así. Luego, una vez ya pintado todo, vamos a introducirlo en los vasos con agua. Y la fibra del papel va a hacer la absorción y entonces el agua va a correr y va a subir con los colores de la tinta. Vamos a sacar más. Es algo lento, pero ahí se puede apreciar mejor cómo sube. Ahí. Bueno, esto ya es algo que he probado hace rato, ya está muy mojado y salió un poco los colores ya, pero es algo así como queda. Y los niños pueden agregar el color que quieran, sus colores favoritos. Ya.
Perfecto, gracias. I think my
You're
microphone was
muted,
off.
Michael.
So thank you again, Maria. I'm interested in feedback people have about how well or how poorly that worked to try and understand an experiment that was presented in a different language. I know we have a handful of Spanish speakers, so for them, it should have been easy enough to understand. For everyone else, I was looking at the transcription. For me, it was okay, understandable most of the time once I finally got it running, but not without problems, both in the quality of what it was transcribing and then translating. It confused it a lot when I switched from English to Spanish. My accent is not great in Spanish, nor is my level absolutely perfect or anything like that. So of course that tripped it up a bit, which is one of the issues. Another issue, probably having the screen shared, which made it possible for everyone to see it, whether or not the link worked for you. Then you need to play around with the windows to see Maria's experiment bigger. So for me, it was not a complete failure and was useful for like learning from, but if people have more input on that or other ideas to try out, please let me know, because I'm eager to come up with solutions for this. But yeah, any thoughts on that? That's a good question. Me claro los colores cuando juntan a la mitad. Yeah, they do mix, and you do you want to? Well, I've grabbed it here. So she had them lined up so that they like it was symmetrical on both sides. But when it's not, then you'd have a color mixing in the middle. Great question. And one more thing on the topic of translation. So next month coming up, Monday, May 5th, same time, same Monday of the month, first Monday of the month, we'll have our annual silent experiment share, where we present experiments without words. And I'm trying to figure out a way to have something fairly smooth where we can type and have things translated live so that we have as little speaking as possible. As we saw with the previous test, software exists, it's just a little bit clunky and messy. So I'll play around with things in the month until then, but if anyone has any ideas or suggestions of other things I can try out, then all the better. But hopefully some of you will take that the silent experiment share as an opportunity to share something, whether or not you might be comfortable presenting in English when everyone else is speaking at at other months. So there's that coming up as well. With that being said, it looks like Nasko's back, and he looks like he has a smile on his face indicating that he's got indicator.
Yes, I do. And of course,
Now it's a frown.
of course, there is this thing when Michael asked me to co-host. Of course, I should have expected for him to expect fire. So in this one, I'll give you fire. So what I have here is just a piece of printer paper, which I have cut because I don't need all of it. I need just a little bit, because the most thing that is in paper is cellulose, but it's not the only thing. There are quite a lot of more things like phosphorus compounds, nitrogen compounds, and potassium, because potassium, nitrogen, phosphorus is what makes plants grow, and those three elements are quite abundant in plants. And so when we take plant matter and we use it, well, those three elements will be abundant in the plant matter. And because we have taken away the lignin, so there's not a lot of nitrogen in there, but the the potassium doesn't have a lot of places to go, so it is still present in the paper. And we're going to check on that, because if we burn the paper, that potassium should go inside some compound. And that compound, of course, the most easy compound that you get from burning in atmosphere with carbon dioxide in it, it will be potassium carbonate, or potash, a stuff with which in Europe soaps have been made for the last 2000 years at least. So what I'll have now is I'll take my safety plate that's made from borosilicate glass. I'm going to really quickly blur my background so you can see more of my working space. And so my safety plate made from borosilicate glass, I'm going to use it to just so I'm sure that nothing is falling on the floor, because I'm in my home. And if I put the apartment on fire, my spouse, who is in the other room, she will come and she will beat me. So let's not burn down the house now. So I'm going to put my safety glasses on. I'm going to hold that paper with the most professional thing to hold the paper with. I'm going to light the paper on fire, of course. And I'm living in the Balkans, so there is no fire alarm going on. Health and safety maxing in the Balkans. So now you first see the black thing, and now it gradually becomes more of a grayish color. So black means carbon, unburned carbon, and little by little it becomes white. So the carbon still sizzles off, and we're left with beautiful, beautiful, beautiful potash, beautiful potassium carbonate. So what I'm going to do is I'm going to put it on the safety, on our beautiful safety plate, and I'm going to take my small measuring cup, and I'm going to blow most of it on my desk, it seems, but I'm going to take some, right, and put it in my cup. I'm going to grab some more that I have blown to the desk, just a smidge. And I'm going to add some water. And now the carbon is not water soluble, so we don't care about it. But what's water soluble, at least a small amount of it, is the potassium carbonate. And not only it is water soluble, but it should be quite basic. So here I have a little bit of phenolphthalein solution, and you see I have grayish suspension here and white solution. So when I mix them together, I get this beautiful, beautiful purple, which means that my solution is indeed basic. So I did catch some potassium carbonate, and what we say in my country when something messes about, I'm going to put ashes on my head and I'm going to wash my hair with it. So this is a nice chemical proof that potassium carbonate, potassium as an element, is present in paper and to extension in plant matter. And it has paper and it has fire. One versatile material that humanity uses for 2000 years, and one thing that made society, the fire. All right, so that was the beautiful experiment with the potassium carbonate, and let's get back to Michael.
So I'm tempted to stop there as a grand finale, but I kind of have one more paper experiment I want to finish with. So what do you guys think? Should we have one more, or should we end with that one? There's at least a couple of nods and
One
smiles.
more.
So
One experiment.
okay, so,
one more.
So we'll have one more, and hopefully the dog barking in the background is caught by Zoom's noise filter a little bit, because it's quite annoying for me, but hopefully not bothering you guys too much. Okay, so one final experiment. This is a little bit of introductory material science. That makes it sound more complicated than it is. But in the chat, I want everyone to write a brief description of paper, like write 1 or 2 words, adjectives that describe paper. And as you're thinking of words to add to the chat, I'm going to explain. This is something I used to do in class with year 5 students, which are like 13 years old in France. And when we'd start teaching about matter and materials, one of the introductory activities, I'd say, okay, describe paper. So in the chat, write an adjective that describes paper to you. Excellent. We have fibers coming through already, and we saw fibers. Maybe you were primed to think of that when we were talking about fibers. Any more words? ¿Puedes describir algo que describe en papel? ¿Cómo es papel? Best material
Liviano.
Something thin. That's a good one. And so Maria was saying it's light as well. So if we say paper is light, so to some of those I can say, oh, this book is made of paper. But if I try and hold it out for several minutes, it doesn't seem that light anymore. So it depends on the paper we're looking at. Paper's hard, but this paper is bendy. Paper's flat. But how about this? Is this flat? And to put us up, I got to microphone. And so there are all kinds of different counter examples we can get. If students say that paper is white, then I'll hold up a piece of colored paper to say, okay, it's not white. And one of the common descriptions we get of paper is that it's weak or it's not that strong. We can bend it easily, we can rip it easily. But as Carlton pointed out that it's fibrous, it's actually quite strong for tensile strength. And if we try and pull it apart without introducing any rips, it is possible. If I pull really hard, I will be able to break it. But I can pull reasonably hard without it breaking. So paper is really good in tensile strength. And that'll be the key to this demonstration. So for this demonstration, and it's the end of the meeting, so time to relax afterwards. Maria, ¿puedes buscar una cerveza, por favor? And so I'm going to pose the challenge, how can I open a bottle of beer using a sheet of paper? And this doesn't immediately seem like it would be strong enough to do that. But if we remember, it's really good in tensile strength. And that's where it, like materially, it shines as a material. I just need to come up with a configuration where I use the tensile strength of this. So this is a trick. This is a trick. So I need to get this cap off with this piece of paper. And this is a trick that I learned from a biology teacher, of all people. One of my best friends. He's one of the co-authors of the IB textbook for biology. But this isn't my camera wasn't showing. I took this sheet of paper, same sheet as before, and folding the paper, and I'm folding it several times. So it gets quite small. I'll fold it in half, actually. And the last time I fold it, I'm going to crease it as hard as I can, so I get as sharp an edge as possible. And notice once it's folded, it's actually reasonably stiff. I mean, not all that stiff, but one of the reasons for that is as it's folded over again and again and again, if I try and deform it in this direction, which I mean, I still can do, then that means the top path is going to be longer than the short path. This top path will be in tension, but paper is strong in tension. That's where it shines. So that's the key to this. I'm going to need a lot of tensile strength. I'm going to fold this over here and fold it so I have a bit of a sharp point here. And hopefully this works the first time. If not, I've got more paper. I don't know if you heard that noise. And I managed with this sheet of paper to open this bottle of beer to enjoy after the experiment shift. And we can open this up again. And you can see it still is just this sheet of paper, no tricks here. Of course, it's got a little bit of a hole from where it interfaced with the cap. But because of the strong tensile strength of paper, I was able to use it in that configuration for this. So with that being said and done, are there any thoughts on either this final experiment or any of the paper experiments you've seen today? Doesn't look like there are many thoughts. So with that, I guess that brings things to a close. I want to remind everyone, next month, same day, same time, not same day of the month, same day of the week. Monday, May 5th, 6 o'clock Central European time, we'll be having our annual silent experiment share, where everyone who's presenting an experiment will do so without speaking, which gives us a neat opportunity to think about the non-visual ways we explain things, but also should level the playing field reasonably well linguistically. So that whether or not you're comfortable presenting in English, hopefully this will be a good opportunity for you to present. So that's coming up next month. With that, Nasko, I haven't had you say much recently. Do you want to give the final remarks and thank everyone, including yourself?
Of course,
Thank you for being my co-host.
Thank you for having me. I hope that you've seen some nice experiments that you can take, or if you have seen them already, that you can think of them in a new ways. And I hope you enjoyed the experiment share. And of course, don't be afraid to share your own experiments in the next one and tell your friends and colleagues and your aunties and your nephews about the experiment share, and bring more people so we can enjoy more experiments and see what's going on. So thanks everybody for being here, and see you next time.